Hello, welcome back to my YouTube channel, Learn Physics Better with Blessing, a channel set up with the aim of helping students who are finding it difficult to understand the subject physics. We started one of the basic topics in physics, which is motion, and we've treated the definition of motion, causes of motion, and types of motion. In case you have not watched the videos on them, please go and watch it because it contains a lot of information about motion. Although we just treated two types of motion, which are the random motion and circular motion. So today I'm going to continue on another type of motion, which is linear motion. Motion is the movement of a body on a straight line. That is, when a body is moving on a straight line, track, lane, form, and pattern. I'll give examples. Examples are a moving car, a car moving at constant speed on a straight road. Another example, an athlete running 100 meters. That is, the athlete is running on a track that is 100 meters long and straight. Another example is a moving train on a straight track. I know you think linear motion and translational motion are the same, but they are not the same. There's a slight difference between them, just like circular motion and rotational motion. In translational motion is the movement of a body from one point to another in space. That is, the body is traveling in space. I'll give an example. A bird traveling or flying from one tree to another. When the bird is flying, the bird is not flying on anything, but the bird is flying in space. But in linear motion is the movement of a body on a straight line. And we use road. Let's use road. A straight road, for example, a car moving on a straight road. The car is moving on a straight road. That is, the car is moving on something. That is the road. But in translational motion, a bird flying from one tree to another, the bird is actually flying in space. That is, the bird is suspended in air. So you get what I'm saying now. So there's a slight difference between linear motion and translational motion. Another example of translational motion is a fired bullet. When a bullet is fired from a gun, which is point, let's say the gun is point A, and is shot to a person, point B, like where the person is, point B. When the bullet is fired from the gun, point A, it travels in space to point B, which is the person, where the person is standing. So when it's traveling, it is traveling in space. It is not on something, it is not depending on something. It is not on a straight line, like it's not on a straight road, it is not on a straight track, but in air. It is suspended in air, suspended freely in air. So as the bullet moves from the gun, point A, to the person to be shot, point B, it is moving in space, and that kind of motion is called translational motion. In linear motion, the body must be moving in a straight line. But in translational motion, it might not necessarily be in a straight line. For example, the bird flying. The bird might not really fly in a straight form. But in linear motion, the body must be in a straight line. So linear motion is a straight line motion, but translational motion might not necessarily be a straight line motion. The difference between translational motion and linear motion is that in translational motion, there is a complete change in position of the body. That is, I'll go back to the example of a flying bird. A bird flying, this is a rough sketch, so I can't really draw like that. So this is like a rough sketch. This is a tree at point A, and the bird is on point A, that is a tree at point A. If the bird travels to point B, that is another tree. If the bird travels, the bird is traveling in space. That's one difference. Another difference is that there's a complete change in position. Like the bird left this point A to point B. There's a complete change. So it's not